Hello friends, welcome to TechGrant. Today we will see why we should use Google Cloud Platform or GCP. As you know or heard in the market, there are multiple cloud service providers like AWS, Azure, IBM, Oracle, DigitalOcean, Rackspace, or even CenturyLink and many other companies. They all are providing same resources. But then why we should choose Google Cloud? In this session, we are going to discuss some key benefits and technologies provided by the Google Cloud. So first, let's revise some of the basics, fundamentals or characteristics of cloud computing. So first is on-demand and self-service. Cloud computing is an on-demand and self-service where no human intervention needed to get resources. We can just connect to the internet uh, and get our resources whenever we need them. Second, broad network access. We can access the Google Cloud Platform or cloud service providers and their services from anywhere, anytime in the world. Then we have resource pooling. These cloud service providers have large resource pools of number of servers and their resources, and they provide the shared resources from that resource pool to the customers. Then is rapid elasticity. We can get the resources more quickly and as needed whenever we need them. We can scale up or scale down the resources according to the requirement. For example, in any festive season or New Year or Christmas holidays, at that time there might be a spike in the usage of those resources. At, at the same time, we can uh, increase our resources or we can scale our resources, and after the spike comes down, then we can scale down it back to the zero even. So we would get less cost for that as compared to on premises or other cloud providers. Third, last thing is measured service. Whenever we used any of the resources from Google Cloud Service Provider, we only or any other service provider, we only pay for whatever we consume or we use the resources. So just like on premises, we bought a server or hardware from a huge amount, and it will be give a cost to us whether we use it or not. But in the cloud providers, cloud computing, we only have to pay till the time we will use it. If we use it for 1 hour, then we have to pay for that 1 hour only. So it will directly affect on the cost of that hardware or cost of those resources to us. So what was happening in the earlier time? Uh, some of the companies collaborate with each other, and they create a co-location facilities where they bought servers and then use them together, where user it was responsibility of user to configure, manage and maintain those servers. Then we were not getting the full efficiency of those resources, so we moved to virtualized systems. In that virtualized system or technology, user was responsible to configure and provider was responsible to manage and maintain those hardware and resources. Then we have cloud computing, where it's providers responsibility to configure, manage and maintain those resources. Depends on the situation. If we want some of the resources like VM to manage, configure, and maintain ourselves, then we can do it as well. But the most of the part uh, will be managed by cloud service provider. And now onwards in the future technologies, we are moving towards serverless, where all those configuration, management, and maintenance are fully automated. We need not to worry about anything about infrastructure or its maintenance, its upgrade, or anything. Everything will be automated, which is serverless. So, Google Cloud Services provide different infrastructure from managed to dynamic infrastructure. First, it provides infrastructure as a service in which it includes compute engine. As I told in our last video about IaaS, PaaS and SaaS, uh, compute engine is the feature provided by Google Cloud Platform where we can manage all the operating system and everything regarding storage, networking, computing. We can manage and perform whatever we want, like we can deploy our applications or install any software. That comes in infrastructure as a service. Then we have app engine functionality, app engine resources in Google Cloud Platform, which comes under the category of platform as a service, where we get a platform to create our applications. So we need not to worry about managing all those resources. And with the combination of both IaaS and PaaS, we also get hybrid technology where Kubernetes engine is the resources provided by Google Cloud Storage. In Google Cloud, in Kubernetes engine, we also we if we want we can manage, or if we do not want, we just let them to manage by Google Cloud Service provider. Kubernetes engine, also known as GKE, Google Kubernetes engine, where we can create multiple clusters and run our applications on those Kubernetes cluster in the containers. We can also install the GKE on premises and bring those clusters into the GKE on cloud as well. Then we have serverless logic technology, where we have cloud functions. In the cloud functions, we also need not to do anything. We just put our code, and that code will be executed automatically without worrying about any infrastructure or any resources. Then we have managed services which are which are having automated elastic resources. The resources used by these managed services can scale up or scale down automatically, like artificial intelligence services or machine learning. So for these services, we need not to worry about anything. We just need to use them, or we can use them as per our use cases. So here we talked about IaaS and PaaS. You must be thinking where is SaaS, software as a service. Google Cloud provides, as it is Google which we used in our daily life for search engine, or Gmail, Google Drive, or Google Maps. So those services which are directly consumed by us or end user on the internet, those are as software as a service, like search engine, Gmail, Docs, YouTube, Google Drive, Google Maps. All those services can be think of as a software as a service for Google Cloud Platform. So we have some parameters on the basis of what we can differentiate between different cloud service providers and even on with the on premises. So first we have infrastructure, what we can get from any cloud service provider or from where uh, we can have those resources either all over the world. Then we have security, because security is the main concern over using the cloud service provider. How the security can be implemented by any cloud service provider, that makes it a major difference with those with its service provider service offerings. Next is a choice for hybrid and multi-cloud. If any service provider uh, cannot force us to just use their service, so they must give a choice to select any multi-cloud services or hybrid cloud services. They must have their resources or tools useful for those services as well. Then we have manageability, then how we can manage its resources, or is it easy or difficult to understand or difficult to manage those resources. That is also a key component here. Then we have integrating innovative technologies. As the technologies are moving so fast in the future world, so we have daily next innovations and the related innovative technologies. So whichever cloud we are going to use, so its resources or tools are compatible those innovative technologies, or they can be integrated with those technologies. That is also a key component and differentiator for the cloud service providers. Then we have open source software adoption. If any of the cloud service provider we are going to use, that must be compatible to integrate with open source softwares, because we some many of the open source tools are more useful than the provided by cloud service provider. So it should be our choice to use any of the open source software, and cloud service offerings should have option to integrate them better. Then at the end we have support parameter, where how we can get the support with that cloud service provider, and how is their support. So on the basis of these parameters, let's see how Google Cloud Platform provide us the facilities and resources. So let's see some of the parameters where Google Cloud Platform provides us uh, the best services and tools and the resources. So first is global infrastructure. Google Cloud Platform spans across 21 regions, 64 zones, and over 130 plus POPs, that is point of presence, across more than 35 countries worldwide. From redundant cloud regions to high bandwidth connectivity via subsea cables, every aspect of GCP infrastructure is designed to deliver services to the user no matter where they are around the world. So we have scale alongside Google's global network. So Google have network all over the world through the subsea cables, and it covers majorly geographic locations like North and South America, Europe, Asia, and Australia. Google Cloud Platform provides us the choice to go with the hybrid technologies or multi-cloud technologies. With the hybrid technologies, we can think of like GKE, Google Kubernetes Engine, where we can use GKE on Google Cloud Platform as well as GKE on-prem, and we can connect together both the GCP and on-prem GKE to the single GKE hub on the Google Cloud Platform. So it will work as a hybrid technology. And for multi-cloud, we can have different technical tools like Stackdriver and other tools as well, which can work on Google Cloud Platform as well as AWS. So their Stackdriver can be used for monitoring, logging, tracing, and other purpose for both the cloud providers. With the Google Cloud Platform's managed cloud native solutions, means developers can write an application once and then run it either on premises, on Google Cloud, or on any other cloud with no change in the infrastructure. That is the beauty of giving choice of hybrid or multi-cloud technologies. We can make applications and services portable and provide consistent experience across on-prem, public, or private cloud without the fear of vendor lock-in. If we need to migrate, meet regulations, or transform our setup, Google Cloud Platform can modernize how we can develop, secure, and operate hybrid cloud environments. Modernize a legacy application or creating a cloud native one with an accelerated lifecycle and no operational overhead, all without compromising service reliability, can be provided by Google Cloud Platform. The easy to manage platform as simplifying operations and product deployment with Google Cloud's fully managed serverless offerings and hybrid and multi-cloud capabilities, where fully managed infrastructure free up the developers by eliminating repetitive tasks. So we can also set up end-to-end CI/CD pipelines in on-prem, hybrid, or multi-cloud environments, which becomes so easy to build them. Many industries and organizations fears about going to the cloud because of vendor lock-in, where Google Cloud Platform allows users or enterprises to use to not to have any vendor lock-in, where if they want, they can use any of the services from any of the cloud or on premises, where most of the enterprises also use open source projects which are generated by Google, like Kubernetes, Istio, Android, machine learning platform, which is algorithm, that is TensorFlow. For security, it's for city security, and we have gRPC protocol and Go language, which is also very popular nowadays. Then we have Chrome browser, which is fast browser also. So many of these or almost all of these open source projects are built or generated by Google and then given to other organizations. And Google Cloud Platform allows to use any of the technologies, avoiding vendor locking. Then we have open API interoperability, where many of the uh, Google Cloud resources APIs are compatible with other tools like Google Cloud Storage APIs are also compatible with AWS S3, and we have Dataproc, Cloud Dataproc, that are compatible with Apache Hadoop, which is a big data techno tool. And then we have Bigtable, which is also having a compatible API with HBase, also a big data tool for columnar database. And then we have Dataflow, which also works with the Apache Beam. Then we have multi-vendor friendly products like Stackdriver and Kubernetes Engine. Stackdriver, which is used for monitoring, logging, and uh, alerting, tracing, debugging, all those purposes that can be used for Google Cloud Platform as well as AWS. And the same Kubernetes engine can be used by any of the other clouds or even on the on-premises. So we can use both the tools with other cloud providers on-premises and with the Google Cloud Platform as well. So enterprises can provision and manage services from Google Cloud Console with integrated monitoring and logging and simplified identity and access management. So then trust and security. The same security technology that supports Google's private global network protects our data as well while meeting industry specific compliance standards. Progressive layers deliver multi-tiered security, detecting and responding to internal and external threats 24 by 7. Google Cloud uses same security setups which it used for its internal services like with Google search engine, Google Maps, or Google Drive, Gmails. Whichever security are used by those services, they are providing the same security setups for Google Cloud Platform tool services as well. As you can see, a small table in the right hand side where we have layered security from bottom to top, whether it is hardware infrastructure security, service deployment, user identity, storage services, internet communication, or operational security. We have layered, Google Cloud Platform have layers from bottom to top where in the hardware infrastructure security, hardware design and uh, servers equipments are custom designed by Google, including their hardware security chips known as Titan. So these chips are more secured and custom designed by Google for their infrastructure. Then we have and their data center securities are 24 by 7 with monitoring by that security cameras and they are also very much secure. Then we have Google servers. Those use cryptographic signatures to make sure they are booting the correct software. Google Infra provides cryptographic privacy and integrity for RPC data on the network, which is how Google service communicate with each other, and that encrypt for inter-service communication. Then we have user identity, where the central identity service use user two-factor authentication, where all the employees and other users, all the employees have their UTF, U2F devices to log into the Google Cloud infrastructure, where auto encryption data at transit is also there. Whenever data transmit from one data center to another data center, that data is auto encrypted. And in the storage services also, data residing in the cloud storage, that is also encrypted, which is known as encryption at rest. Google Cloud Platform also allows to enable hardware encryption support in hard drives and SSDs. They also have that hardware encryption support there. Then we have internet communication, where Google front end is the service where all the request comes first, and that Google front end have the security for denial of service protection that is designed in the Google front end services which are having intrusion detection system with in the operation security, and Google Cloud Platform also have techniques to reduce insider risk for any phishing attacks by the employee, as so they are instructed to use their YouTuber, and for their software development practices they have a two-party review for any source code changes. So that is how Google Cloud Platform built the security from bottom to the top, from hardware infrastructure to the operational security. Then Google Cloud Platform also provides some additional services like budgets and alerts, billing exports, reports and quotas, where we have budgets specifically defined either per billing account or per GCP projects. Budgets can be of fixed limit, or we can set them with other metrics like how many how much percentage we have used as compared to the last month, and then we can set up alerts on the basis of that. We uh, if we have used 50% or 70%, 80%, 90% or 100%, by default or generally alerts are defined at 50%, 90% and 100%. But if you want if we have set our budget at $2,000 and we have set up alert for 80%, then we can get alerts on $1,600 of the uses. Then we have billing export. Billing exports provides a detailed billing information for the detailed analysis, which can be done using the BigQuery, or that information is stored basically in cloud storage or BigQuery dataset. That detailed information can be analyzed to reduce the cost and usage of the resources. Then we have reports, which is a visual tool to monitor the expenses, that we can check there how much we are having expenses over the resources. So we can control our resource usage on the basis of that. Then we have quotas. Quotas are designed to prevent overconsumption of resources due to any error or malicious attacks. So quotas are basically of two types: rate quota and allocation quota. In the rate quotas, we can have like 1,000 requests per 100 seconds for Google Kubernetes Engine API requests. That can be set on project level, and it resets after specific time. So if we can take it like if we have crossed our 1,000 requests per 100 seconds today, then it will reset at the end of the day, and from on tomorrow we will again get those rate quota for 1,000 requests. Second is allocation quota. Allocation quota means how much resources are allocated to us, which we can use up to that limit. So just like we have a rate allocation quota of 5 virtual private VPC networks per project. So if we want to increase these any of this quota limit, we can reach out to Google Cloud support team to increase these quotas. So these are the facilities provided by Google Cloud Platform, so, which can differentiate it from other cloud service providers. So let's have a look on the map to get the visualization of regions, how many regions we have. So we have 21 regions, 64 zones, and 134 network edge locations across available in about 200 plus countries and their territories. Recently, Google Cloud Platform has added new regions named as Zurich, Osaka, and Seoul. And for other regions are planning to edit or expanding the locations. You can see where the light light balloons in white color, which is locations as Salt Lake City, USA, and then we have Las Vegas, and then Jakarta and Warsaw in Poland. So here we can see here is Jakarta and here Warsaw in the Poland. So Google Cloud Platform's private software-defined network provides fast and reliable connections to the users all around the world. In this diagram, you can see the connectivity of all the regions through the sea cables or the fiber. This is the fiber connectivity where blue lines denoted the Google Cloud Platform current network and green lines are showing submarine cable investments where it connects through the seas. According to reports, 40% of world's internet traffic goes goes through this Google Cloud network to get highest throughput and lowest latency for the applications to the users. The Google Cloud Platform have network interconnects at more than 90 internet exchanges and 100 plus point of presence. When any internet user sends traffic to Google resources, Google responds to users' request from edge network location, providing lowest latency. And the Google's edge caching network cites content close to end user to minimize latency. This Google's global network built on the same future-proof infrastructure that returns billions of search results in milliseconds, serves 6 billion hours of YouTube videos per month, and provides storage for 1 billion Gmail users. Google Cloud infrastructure is protected by more than 700 experts in information application and network security. Apart from this, Google works on 100% renewable energy. Google matches 100% of the energy consumed by global operations with renewable energy and maintains commitment to carbon neutrality. So, whenever we choose Google Cloud Platform to run our compute, store our data, and develop our applications, our digital footprint is offset with clean energy, which reduces impact on the environment. Whenever we choose any cloud platform, we think about its price, security, openness, and of course, its availability of its products. But we should also consider the environment. A sustainable cloud is not only good for the environment but good for our business as well. So Google has a commitment that for each unit of electricity they use as a company, Google will purchase an equal amount of renewable energy. So Google is not only providing the best services, best tools, but also saving our environment. So at the end, how we can forget about discussing about the cost because the most most effective factor is the price and the cost. So the Google Cloud Platform is the only cloud service provider which introduced per second billing. So it also provides some other functionalities or benefits to the users where billing in sub are increments. So uh, our resources will be charged in the per second basis, and and in the billing account for compute, data processing, and other services, the will be incremented sub hour in the every hour, starting of every hour. We would get discounts for sustained use, where which will be automatically applied to virtual machines when we use them over 25% of a month. Then we have discounts for committed use. If we have our resources for long time of duration to use, then we have to pay less because we are committing that we will use those resources at least a long term. So for those long term workloads, we will also get discounts. And then we have discounts for printable use. So printable are when uses for less amount of time. So whenever Google Cloud Platform require those resources, it will get those resources. So we have to pay less for those interruptible workloads. Then we have choice to choose custom VM instance type. So we have to pay only for the resources we need for our application. It's not like that we have specific CPU and memory resources for any virtual machines. We can adjust those CPU and memory according to our requirements. Then we have some small overview of the products which are provided by Google Cloud Platform globally. We have a networking, big data, machine learning, security, developer tools, and management tool products. Apart from these, we have compute and storage as well. In the networking, we have Cloud CDN, Cloud Interconnect, DNS, and Cloud Armor for security and Network Intelligence Center to monitor all our network. Then we have big data tools for products where we have PubSub, Google Cloud Studio, Cloud Data Lab, Cloud Data Pro, Data Fusion, Data Flow, and others tools as well. Then we have developed some of the developer tools, Cloud Build, Cloud Source Repository. We have machine learning products like Cloud Vision API, natural language processing, speech to text, text to speech, cloud translation, and recently they have cloud video translation as well. For the security, Google Cloud Platform provides Cloud DLP, which is data loss prevention APIs. Then it have Cloud Security Command Center and the identity and access management used to provide access and permissions to all of the resources and users. Then we have management tools where we have Stackdriver for monitoring, logging, error reporting, trace, debugging, and profiling. Then we have Cloud Deployment Manager and then Cloud Endpoints, Cloud Cell, Cloud Billing API, and Resource Manager. So we have these tools. Apart from this, we have many more products as well. So we will see all those products, how they use, how we can integrate them to each other to build our applications or to get insights into the data or to use as big data technology or in the container technologies. We can use all those products. How we can use, we will talk or see in the future videos. So that's all for this video and this session. Thanks for watching. Bye.